thank you to be here, even if the night has been shortened. I hope for everybody, I hope you have been outside this night, yeah? You were able to see the polar bears? Yes? Nice. So it was our first sight of the trip, but for sure not the last one. I hope it was a good introduction to see those polar bears very quiet, a mom and a cub. And let's hope we will find others that will be more curious and come to us today. We cross fingers. So I think you didn't have really like a talk about the sea ice yet to talk more about it, yeah? So I will talk more about sea ice today because we are sailing on sea ice for days. You have been walking on sea ice, almost sleeping on sea ice, and there's a lot to know about it if you want to appreciate more. So I will come back to the basics just to be sure then everybody is clear with all what I will talk about today. The basic, of course, what is ice? I think now you all know this is some water that is frozen, so it means water at a solid state. You know, water can be liquid, solid, or gaseous, depending on its temperature and pressure as well. But usually, what is the temperature at which you start to freeze water? Zero, we agree. But in the Arctic, it's not zero because all those who have done the polar plunge, maybe you were aware that it was very cold and it was less than 0 degree. It was about -1 degree Celsius when you jump in the water, but it was liquid because the water is salty. It's ocean, it's salty. And when the water is salty, you need a lower temperature to start to really freeze in a good way, solid way, some water and make some ice. So usually polar water start to freeze around -1.8 degrees Celsius if you want to build really sea ice. On the Earth, we can separate two kinds of ice. We will talk first about marine ice. So marine ice, it's the sea ice. It's ice built by the freezing of the surface of the ocean every year because of the cold. Okay, so it's salty water. And on the other side, you have all the other kind of ice. We call it terrestrial or continental ice. And it's all the other, it means it will be ice that you find not on an ocean, but on a land. So it can be ice caps, glaciers, ice shelves, icebergs, permafrost as well, you know, this frozen ground that we find in the Arctic, rivers and frozen lakes and snow. All this is comprised in what we call continental ices. This is the one that we will discover when we will arrive in Svalbard. For the moment, we saw only sea ice, marine ice. And continental ice, just explain only one slide because the talk is not about it, but soon we will see some glacier, and it's nice to understand how it's built, this continental ice. So you see, it's not at all from seawater. It's you have a ground, a continent that is always cold because it's in a polar region or because it's high elevation, like top of a mountain. It's snowing, and as it's always very cold, the snow stays on the ground, it's never melting. So you accumulate snow layers more and more and more, thicker and thicker. When you accumulate those snow layers, they densificate on the weight of the new fall falling. So at some stage, it's so dense that first you don't call it snow anymore, you will call it firn. This firn, so it's snow, very dense, but still porous. It means you still have some air communication and traveling from the surface into the firn. Okay, it's open. And still it's continuing, you have some new snowfall falling, and you have a bigger and bigger thickness of snow, and at some point it's so dense, this material that densificates it, that you will not call it firm anymore because the air is not able anymore to travel to the surface. It's gonna get trapped into this material that we call ice now. So trapped under the shape of air bubbles. And the ice will also change its property, it will crystallize. Okay, so you have snow, firn, and ice below. And because polar regions are also desert, if you are at the top of Antarctica, it's snowing only 2 centimeters of snow per year. You need sometimes 1,000 years to reach this depth where snow starts to be ice. So it's very, very long to build ice in those places. Okay? So now I'm gonna stay on sea ice for today, so it's totally different. Sea ice, you've seen it already. It's again the freezing of the ocean surface every winter because of the cold, so it's a seasonal phenomena. Ice built in winter, melt in summer normally, and it's doing again every year. And here you have the difference of extent of sea ice in the Arctic for average in summer. For the minimum, so the minimum is in September, and on the left it's in winter, the maximum extent around January, February. So you see the surface of extent in winter is really huge. It's almost the double the surface of the Arctic. And it's exactly the same in Antarctica. The sea ice in winter, it doubles the surface of the Antarctic continent. So this is a huge phenomena that will have strong climate effect all over the world because it's really big scale. Okay? And then the thickness of the sea ice will depend on several parameters like the water temperature, the air temperature, the insolation like the cloud cover, wind effect as well, the ocean current, the salinity of the water. All this will have an effect on the kind of sea ice that we are gonna find this year. And yeah, this is a map of Antarctica. It's the same sea ice in winter is freezing all around in the South Pole. So how this sea ice is built? I'm sure you saw already some part of it because around the ship we are lucky enough during this trip to have so quiet, amazing conditions that sometimes you can see a thin layer of ice freezing this morning, yesterday night as well, of different kind. But this is a summer freezing, like only during some hours. If you really want to build the sea ice that's gonna stay for 1 year, you have different stages, and this really takes time. It can take weeks to build the sea ice that's gonna stay then for the winter. So what happened? So you need first to have some very quiet conditions like we have today and yesterday. No wind, because if it's windy and the crystals start to freeze, anyway they will be blown away and you have to do it again. So quiet condition during several days maybe, and a very cold ocean temperature, so cold enough as well. So if you have this, some small crystals will start to freeze at the surface of the ocean. We call it grease ice first. I will show you some picture after of the different stage. And fragile will be the small ice crystal you can see with your eyes floating on the water like that. This will be a first stage. And when those crystals freeze, what happens, that is very important, is that the salt that was contained into the water will be extracted. Most of it, it will not stay into the ice. It will be extracted and fall down into the water that is just below. So it means the sea ice, if you test it, it's still salty because it's not 100% of the salt that is extracted, but it's really less salty than the ocean. And the water just below will be very salty and very cold, so it will be very dense. So what will happen with this water? It will fall down because it's heavy of cold and of salt. So it's gonna fall down deep, close to the ocean, the bottom of the ocean. And this phenomena is what we call the engine for the big global thermohaline circulation. It's currents, ocean currents that will flow all around the world, and that takes birth, so they're born here in the polar region by this phenomena. So because so the water is cooling down, and then it's traveling on the bottom of the ocean in other latitude, and to replace it at the surface, because you have to replace it, it will attract some warmer light water at the top, and this creates also some surface currents that are warmer. Okay, so it's like a loop. If you look into the sea ice column, you find some small cracks, and we call those cracks brine channels. It's by this channel that the salt will be extracted first, so it's going down by gravity, down into the water. And then these cracks will be useful because some microalgae, some bacteria, some small, maybe some very tiny zooplankton will be able to come into these channels during summer and to stay there for winter. So they will be protected. They will be like in a sleeping mode in winter, because in winter you have no more light, so you cannot do photosynthesis again. All the wildlife is like in a sleeping mode, but at least they are protected into these brine channels. And so you will see, I will show you in springtime, suddenly they will wake up. Just a picture as well to show you. Sometimes when you build some young sea ice, you can see these beautiful flowers. We call them the frost flowers, because a small part of the salt will be extracted not by below but by the surface. And so with the contact of the atmosphere and supersaturated salty air layer, it's creating some very beautiful flakes like that. They don't stay long, they stay some days and then they evaporate again. But sometimes we can see some when it's quiet like that around the ship. Then we have many different words and classification to talk about sea ice depending on the age and the thickness of it. So I will just say some vocabulary for you. But it's quite easy one, and most of the time it's in English, so it's easier. So the sea ice that is very young, like less than 10 centimeters thick, we call it new ice, because it's a very new one. Then between 10 to 30 centimeters, it will be young ice. This young ice is already thick enough to be able to walk on it. And even more, 30 centimeters, you can maybe snowmobile. It can be very solid very rapidly. You don't need a huge thickness to be able to walk. You just have to be careful at the beginning and test it. And then when it's more than 30 centimeters, you call it annual ice, because it means it will be the 1 year old ice, the one that stays the whole winter, and then it will thicken and thicken during all the winter, and at the end it will look like what we have seen at the North Pole, 1.5, 2 meter thickness. This will be the thickness of the sea ice after 1 year before melting. Okay. Sometimes in summer the sea ice doesn't melt because maybe we are at North Pole, it's very cold, or maybe because it will be in a dark protected shadow area in an embayment, I don't know. And so the sea ice will stay during the summer and it will continue to freeze, and so it will stay maybe 2 years or 3 years old. 3 years. We call it pluriannual ice or multi-annual ice. So this ice will be the sea ice will be the thickest you can find in the world. It can be 3 meters, 4 meters, 5 meters, 6 meters thick sometimes. With the charcoal we met sometimes very, very thick ice, multi-annual, when we go to North Pole, when we go to East Greenland in springtime as well. During this trip we see that now most of the sea ice we met was 1 year old, and this is not the good news, because what is observed now because of the global warming is that the multi-annual ice at the point of the morning is more and more rare. So the ice is younger and younger because it's melting almost all the time now in summer. That's why also we have less. So this is a picture of the first stage of formation of sea ice. So you don't see sea ice at all, but maybe you see this effect like a greasy water, like if you have fuel on it. So it's what we call the grease ice. It's the first very tiny crystal of ice freezing on the ocean. And then there's different stages. Say so. I don't have the fragile one. But after a while, so all these tiny crystals, they will collide and stick together, agglomerate. And there's some stage we call the pancake. So you can see they create some small shaped pancakes of ice. Sorry. Yeah. And then you have different stage of pancake. You have the small pancakes and the middle pancakes and the big pancakes because they stick together and they do more bigger and bigger plates. Very nice. So here you can see as well some small pancakes starting to grow. Here you have a sea of small pancakes, but what is very interesting, for example, on this picture we were really able to see all the intermediate stages. What was really interesting, you see in this one, for example, so you have like a middle pancake and inside you can still see the shape of the small pancakes. So you understand more how it does work. And then it's gonna do same with big scale. So this time you have those big plates also sticking together that now cover almost all the ocean. No more open water. You feel like if it stays cold like that during one day more, it's gonna be okay to build the sea ice for the winter. And this picture was taken on board this ship in the Ross Sea last year during the trip back. And we really have been met by the winter in the middle of the trip. We didn't expect that the winter will come in 1 week. It was starting in Antarctica and all the ocean in a few days was freezing around the ship. It was amazing, I mean really interesting and beautiful, but the ship was careful as well not to get trapped in it because after you overwinter. So all the stages here, yeah. And sometimes you have another effect, and it's more what we can see during this trip around the ship. We will not see pancakes that are more for the winter, but very often you can see at small scale some very thin plates of surface water starting to freeze. And you see this make a big plate form, but it's still very thin. You cannot walk on it. It's maybe 1-2 centimeters thick only. It's still transparent. This we call it nilas, and it's very often it's the case when it's really quiet conditions. So all a big area of water will freeze in the same time. You see, it can do this. This is sea ice freezing. And finally, one day, you have built your sea ice for the winter. So, for example, when you are close to a coast, the sea ice will be attached to the mountain, to the coast, to the edge. This will really help to build it as well, to extend it, because it's more solid when it's attached. And we call it fast ice when it's still attached to the coast. And you're able to walk on it and to use this sea ice for the whole winter. So as I said already, it will continue to freeze and to thicken, by the top by some snowfall, but by the bottom by other ice coming to stick to the first one. So you can work, you use the tool, you saw already our team of assessment on sea ice using this tool. It's a Greenlandic tool that we bought in Greenland, and now we know how to make some. It's how they use it to test the first ice before going to walk on it. Because, and you experienced it already, you saw sea ice was not so flat. It's not so easy to walk on it. You can have big ridges. You can have, on the contrary, some rivers, some holes, some maybe test the melting ponds as well. Because below sea ice, don't forget that you have the ocean. So you have the effect of waves, of tides. It's moving all the time. You feel that it's like immobile, but it's not at all. All is moving. And you can have big compression, big pressure between the original plates that make these big ridges we have seen. Sometimes they can be almost 10 meters high. You see this kind of, of structure, of feature, some rivers, some foldings. Here was a very nice ridge. So you see this will be the boundary between two big plates that collide together and undergo a lot of pressure. And in springtime, what happened? Suddenly, so the sun is back step by step, so the ocean warms up, and so the sea ice will start to weaken, to be warmer, to melt as melting points sometimes, as we have seen around the ship. And if you have a big storm, for example, you often have storms in springtime, it can really break up the sea ice on a huge area in a few hours only, and then it's done for the year. So we call it the breakup. It's the moment where all the winter sea ice will break and then will drift until it's totally melted. It can be quite impressive and very, very fast. I mean, oh, does it work? Yeah. I show you just, it's a very short accelerated movie I took in Antarctica. Just imagine before I start. So you will see some open water. 1 hour before this storm, there were absolutely no open water on this picture. All was totally white, frozen of 1-year-old sea ice to the horizon. And the storm started, and all have been blown away in 2-3 hours because it was strong wind. And you can see on this here, you see the plates breaking. This is a small black dot, it's penguins. So they are trapped on the plates. And the iceberg has been released as well because they were trapped on sea ice 1 hour before, and then they are able to travel again, to float again. And look here, you will see, so it's accelerated, but it's very strong wind, maybe 150 knots, 50 kilometers an hour. Yep, a new one, the penguin. So this is a kind of breakup we can observe. I just wait for the pleasure because I think at the end you have 2 small penguins coming here. Looking at the show, they like, what happened to our sea ice? We cannot go and play again and go far. Yeah, so quite impressive. And yeah, just here. Look! Ah! So, sea ice, now you understand, is an environment very, very important for wildlife. Maybe it's not instinctive because when we were at the North Pole, we didn't see a lot of wildlife. We have seen one bird the second day. For those who have seen this fulmar, the most adventure fulmar in the world, it was flying around the ship. But there were a lot of wildlife, simply it was below sea ice for most of it. I told you at the beginning, so that inside the sea ice there were some microalgae that were able to spend the winter like sleeping in the brine channels, and then when spring is back they will wake up with a light back, and so they will move down to the bottom of the sea ice where they will be able to undergo the photosynthesis. They have nutrients, some light from above, some water, oxygen, and then they will grow again. So we will see some algae on the bottom of sea ice. I'm sure you have seen some when we are sailing, and we will see more probably tomorrow because now we'll be closer to the coast. You will have more food, more nutrients in the water. So sometimes the sea ice doesn't look like so blue like today. It will be green, brownish, red sometimes. This is algae that are sticking to the bottom of sea ice. And it looks like those, if you look at a microscope, those ones are called diatoms. It's the most common microalgae you can find in polar regions. There's everywhere in the water. And they are very important because they are the basis for all the food chain and all the ecosystem living in the Arctic, the marine ecosystem of the Arctic. It means this algae will feed the zooplankton, so the first tiny animals. They're gonna come and feed from these algae as grass. And then the fish will come to eat the plankton, and the seals will come to eat the fish, and at the end the polar bear will eat the seals. But all those animals, all the ecosystem depend on those algae, and those algae depend on sea ice that protect them, enable them to have nutrients and to grow on it. You see this picture? Yeah, sorry. On this picture, if you look, sometime if you go and dive under sea ice, you can see this. So it's not white at all. It's not the same landscape that above. It's what we call some underwater grass. So all this will be eaten by amphipods, by tiny crustaceans, as krill as well in Antarctica. Like this shrimps, they will like it a lot. So it really provides the food at the beginning of the spring. Also, it will release some iron that will help to fertilize the ocean. So it's very good for the life in the ocean. And another thing I will come back to later. This is algae, so it's vegetation. It's exactly like trees. So how do they breathe? What they breathe? No, like a forest, usually how it does work. They're breathing. Yeah, they will absorb carbon dioxide and they will release oxygen. So this is very important for the ocean, as the trees are important for the atmosphere, because it means it will absorb the carbon dioxide. Carbon dioxide, we don't like it a lot, we know that. And it will release the oxygen that will be used by all the animals and the wildlife then. This carbon dioxide is also the one that we put into the atmosphere when we pollute, when we increase, the greenhouse gases. It's carbon dioxide. A part of it will dissolve into the ocean. And once dissolved, it will be used by those algae. It means the ocean today is the main sink of carbon dioxide for the planet. He is our best friend. He is the one cleaning what we put in the atmosphere. The ocean today absorbs 30% of the carbon dioxide that humans put into the atmosphere. So if we have not ocean and this phenomena, we will have even more warming, bigger greenhouse effect. So this is a scheme showing what I said before about all the food chain and the polar ecosystem based on this algae and on the sea ice. So you understand that if sea ice conditions change, this will have an effect also on all this wildlife. For example, they will have to adapt now with the global warming. We know that there's less sea ice. The sea ice starts to freeze later, and it's melting earlier than before. So the duration of sea ice will be shorter. So animals will have to follow sea ice to adapt to these changes. Sometimes they will need to stay in cold water, so they will migrate to the north. So the other, like if the fish migrate to the north, the seals will have to find where the fish are, so they will maybe also migrate to the north. So all is changing. Something else important for the wildlife about sea ice is in spring. So you see this picture is fast ice. We don't see well, but there were a coast on the background. So the sea ice, it was in summer, the sea ice is still attached to the coast, so it's what we call the fast ice, and you have many seals sleeping on it. So it was summer, so they were really only sleeping, so no problem. But in spring, what they do, the seals, they come on the fast ice to give birth, because they need to give birth on sea ice. The young pup, when they're born, they are not able to swim straight, so they need to be with the mom on sea ice. So also, it's why sea ice in spring is very important for wildlife like seals. It will be the same. This was in Antarctica, but it's exactly the same happening in spring. That's also why with this kind of ship, we are careful when we sail in springtime in East Greenland, for example. We don't break the coastal fast ice, because this fast ice is very useful for wildlife. In summer, like now, we are sailing in drifting ice, so it's absolutely not the same. There's no problem to sail through, and the pup are already in the water for a long time. Okay. And at the end, of course, sea ice will be very important for all populations living in the Arctic. Inuit people, Greenlandic people, Russian people, because they are living with the sea ice most of the time. I mean, 9 months a year or almost, they have sea ice close to their village everywhere, so they travel on the sea ice with sledge, with snowmobile, with cars, and they fish and they hunt on sea ice, so they really need it. It's also part of their culture and part of their resources. And the fact that the sea ice decreased today is a big problem for population there, because they also have to adapt very rapidly to very rapid changes that they are not expected, that they don't know these conditions. And they have some old knowledge about all this environment that has been transmitted orally by the old generations. And this knowledge has to be changed now. And it's not easy, because they discover, it's going so fast in the Arctic, the changes, that they discover it year after year. And for example, last year in Canada, in North Canada, one older Inuit told me that so last year he went through the sea ice in spring twice with his snowmobile. So he has to go to the hospital twice because he was in the water. I mean, it's really a problem. Whereas he was traveling in a place where he's used to travel for 50 years without any problem. But for first time now the sea ice is weak just at this place. So now he knows that it's dangerous to go, but you learn in the same time. So it's tricky. Same for fishing. If they are used to fish at a special place in spring, and now they come and the fish are not here anymore because they follow the water maybe to the north, they will have also to adapt. But some of them are happy because also the fishing season with by boat will be longer, and for them it's most of the time more easy, more efficient to fish from boat than from the sea ice. So you have also aspects that can be positive. Another negative one will be coastal hazard. Like you can see here, this house into the water. When you have sea ice that is attached to the coast, some flash ice, it protects the coast from the storm effect, especially in spring. So the wave will not damage the coast because it's protected by the sea ice. So if you have no more sea ice in spring at the moment of the big storm, it will damage very easily all the coast, and you have huge erosion because it's very weak soil most of the time. Also because they are permafrost, like frozen soil that start to melt, so they are very liquid or easy to erode. And some village, they have to really move totally the village away, far from the coast, to rebuild it because they are going into the water very rapidly. So what will be the link between sea ice and climate? I told already a lot about it, but just to summarize. So I said in the Arctic the warming is very rapid, more than in most of other places. Why? Because we observe what we call the polar amplification. This phenomena is due to the albedo effect. So this polar amplification means for average on the Earth today, the global warming is about plus 1.2 degrees Celsius. But in the Arctic, it's plus 4, and in some places it even reached plus 5 degrees Celsius. So it's just totally huge. It's like a mirror of what can happen to us in a few years if we keep going, but then they undergo already a huge warming. Why? Because of one reason, it's not the only one, but one reason is the albedo effect. You know that when you when it's summertime and you prefer to wear a white shirt than a black one because in black you feel that it's too warm. And it's a reality. When you have a surface like ice, white, very light, what happens? So the sun radiation come on the ice and will be almost totally directly reflected. So goes again back to the atmosphere.